Hello.
Hello.
Hello. Yes. Hello. Yes.
Hello. Hello.
Okay. Yes, sir.
Yeah.
We can start at this moment.
Yes. Yes. Good afternoon, everyone.
Good afternoon.
Good afternoon, sir. Good evening to everyone present here. I hope everyone is doing well in the course of this pandemic, where we have been constantly fighting to survive. Today, on the 27th of October 2021, I, Shreya Datta, a member of the IET chapter and a student of the EEE department of IEM.
I, Riya Kumari, a student of EEE department of IEM and a member of IET,
have gotten the opportunity to conduct this webinar on IoET, Internet of Energy Things. First, I would like to introduce Mr. Shushanto Ray, Secretary of IIT Kolkata Network, who received his BE and ME degrees from Electrical Engineering Department, Jadavpur University, Kolkata, India in 2002 and 2008 respectively. Presently, he is an assistant professor in the Electrical Engineering Department, Jadavpur University. Before joining Jadavpur University in 2009, he has worked as a scientist in Defense Research Development Laboratory, DRDL Hyderabad, one of the premier laboratories of DRDO India. He was a visiting professor of UPV, Spain in 2019. He received IEEE PES Outstanding Engineer Award in 2018. He is also Secretary of IIT Kolkata Network and Secretary of IEEE PES Kolkata Section. His field of interest includes development of embedded systems, design of electrical machines, fault analysis of electrical machines, BLDC motor drives, etc.
So thank you, Shreya. Am I audible?
Yes, sir, you're audible.
Thank you, Shreya, for this nice introduction of mine. And I think myself privileged to say something about this today's topic, which is Internet of Energy Things, I think, IoET. And you should know this in the last century, in the late 70s, the smart cities, there was a term that time that was a buzzword, smart cities. But that was a dream that time. But at this century, now we are in 2021, we can say that that dream now we can see in reality. Okay, so how it becomes possible that if we can analyze, so we'll see some technologies in this last 2 decades have developed. One of them is Internet of Things, and then another is mobile computing, passive computing, wireless sensor networks, cyber physical systems. So these are the technologies that actually revolutionized in these 2 decades, last 2 decades. So therefore, we can say that today, in this 2021, so that smart cities is not no longer a dream; it becomes the reality. Okay, so and the IoET is the extension of IoT, as I understand. So that is a building block of also the Industry 4.0, and our energy sectors are very much deploying this particular technology in their infrastructure. So this is very much important for today's era, and you should know, you should have some exposure of IoET. I think today's speaker will definitely will enlighten you with this particular topic. So thank you very much with this, and I think you will enjoy this particular seminar. Thank you. Thank you very much.
Thank you so much, sir, for your kind presence. Now, I would like to call Professor Tapas Kumar Datta, HOD, Electrical Engineering Department, IEM. We would like you, sir, to share your thoughts on the webinar with us.
Is Tapas sir present?
Yes. Okay.
I think sir isn't present here.
Am I audible?
Oh, yes, sir.
Okay. At the outset, let me heartily welcome Dr. Devashish Dey, Professor of Jadavpur University and Director of School of Computational Engineering. And I would express our gratitude to him to introduce ourselves to a frontier technology, that is Internet of Energy. Now, a lot of work is going on in IoT, as Mr. Shushanta Ray told. Lot of applications are there in industries, and this field is getting explored more and more for making the system automatic. I don't have much idea about Internet of Energy thing, but I can understand from the title that it is the extension of IoT for making automatic energy infrastructure. That means application of this IoT concept in the energy sector. So that is a very new concept. Now all these interdisciplinary researches are going on to harness the benefit of one discipline into the others. So that is why I was telling we are grateful to Dr. Dey for introducing our students and our faculties into a new subject, that is Internet of Energy things. I will not take much time because I told you, I confess that I don't have much idea about this. Anyhow, I will look forward for the talk of Dr. D. Thank you.
Thank you so much, sir, for the valuable speech. Now, I would like to call upon Professor Arun Kumar Bor, Principal, HOD of Electrical and Electronics Engineering Department of Institute of Engineering and Management, Kolkata, to say a few words.
Okay, Shreya, am I audible?
Yes, sir.
Okay, KB sir won't be there. He has just informed me. So you continue.
Okay, sir.
Okay.
So I would like to call Mr. Shankar Nath Mukhopadhyay, Chairman of Kolkata Local Network, is a graduate in Electrical Engineering of Jadavpur University of 1983, and who has about 30 years of experience in power sector, worked in GEC, Tata Power, and CESC Limited. He has experience in operation and maintenance of generation and distribution of electricity, has expertise in power generation and distribution of electricity, load flow, load dispatch, and efficiency improvement in power utility. He has also had experience in load forecasting, network planning, and techno-commercial functions in power business. Since last 10 years, he is head of the Asian Institute of Power Management, the training and consulting unit of CESC, and played a key role in expanding the institute to India network. He has proven expertise in business development, in distribution business, and franchisee operation. He is Chartered Engineer of the European Council, the Chairman of the Institute of Engineering and Technology, and an energy auditor. He is also a faculty of Jadavpur University on Power System in Power Engineering Department and executive member of Energy and Environment Committee of the CII and Bengal Chamber of Commerce. Sir, we would like you to share your thoughts on the webinar.
Thank you so much. Now, at the outset of my deliberation, I convey my heartfelt thanks to Institution of Engineering and Management and their professors for inviting me to say a few words in the August gathering. The subject is Internet of Energy and Technology, I can say, IoET. I mean, Internet of Things we say, but this is Internet of Energy things. And obviously the technology is a part of it. Since I have been working with energy since the beginning of my career, I feel extremely happy to share my views because I have that opportunity to see the changes taking place in this power technology field. In fact, I do not have any doubt to say that today, in Indian perspective, energy is the most coveted subject nowadays. And the investments which is going on, this is primarily covering energy, and the development of India is also concerning energy. All you know that India is a country with 138 crore people. Till date, our per capita electricity consumption is abysmally low. Our per capita electricity consumption is last year recorded 1208 unit, whereas the global average is above 3000. So we are almost 1/3 in energy consumption, particularly in electricity consumption. If you talk about global energy consumption, which is around 76 gigajoule, in Indian respect, it is 24 gigajoule, which is also 1/3. But we are the 5th largest economy in the world, and we are vying to be at least holding the position of 3rd largest economy. We are trying to move towards $5 trillion by, say, 2027 to 2030. In electricity, we are having an installed capacity of 388 gigawatt right now, with about 100 gigawatt in renewable sector. And all you know that the threat of global warming is questioning our sustainability. So we are also very, aggressively setting up renewable power plants, renewable energy generation, augmenting storage, and expecting around 175 gigawatt by end of 2022, with having target of further addition of 100 gigawatt by 2027. And even some are expecting that we will be having 450 gigawatt of renewable energy by 2030. It indicates that how keen we are in implementing renewable. At the same time, keep in mind that cost of energy is also increasing. So if these are the requirements in one side, and the other side we need to balance with the available resources and distribution of electricity. So we have been, in the last few years, in the past period, we were looking for concentrated generation, large-scale transmission and distribution. Right now, our thought process has changed. We have diverged to distributed generation, small-scale generation, and local level distribution. We are thinking from large mega grid. Right now, we are thinking of setting up microgrids. We are trying to sensitize generation usage or electricity usage based on the requirement. But how these things is possible? This is being made possible with the usage of Internet of Energy Things, where it is a combination of sensors, where it is a combination of various logics, softwares, and which is making it possible to give us the optimum requirement of energy, be it in industrial field, be it in domestic field, be it in medical field, be it in education sector, everywhere. You feel the energy is controlling the parameters, controlling the human requirement, it is controlling the society, and these energy requirements are also getting controlled with this IoET. How this is being controlled? That is the technology, the process of technology usage. But earlier, when we didn't have microprocessor, we didn't have computer, we didn't have internet, we didn't have sensors that that high degree sensitive sensors. So the problems were different. In fact, I am sharing you a very small example which will exemplify the thing in a lucid way. In fact, I told Nirban that I would be a bit late to join in the program because I had some other assignments. So I just reached my office just 2 minutes back. And my room was, jet black because the room was switched off. But it was not switched off by switching off any common switch. It was off because there was no occupancy in the room. I was not there. As soon as I entered, the sensor could understand my presence and the micro switch got switched on and light automatically came. When I will leave the room, the light sensor, the occupancy sensor will sense my absence, that there is no living thing, nothing is moving around. So it will get automatically switched off. And such energy saving is being done. It's a very simple requirement, and these are the requirements which are developed by today, which is cutting down the cost, saving energy, and making things much usable in a better. We are talking about smart city. We are talking about smart grids. What is smartness? Because things are being done automatically. They are having this intelligence to understand the situation and act. Who has given the intelligence? We people, we have inducted that intelligence within them through programming, through sensor applications, and making an inbuilt circuit, connecting it to the mother network and getting signals, interactive signals, which is coming from the mother network and sensing to the device, and device is also sending sensations to the mother authority. So these are the modern technology which is being used. So I request all my friends to be very sincere to learn this program, get acquainted with the new technology, learn things first, and I expect immense opportunities waiting. Thank you very much for your kind patience. Thank you very much once again for inviting me. I could try to share some of my experience, and I'm telling you very sincerely that tomorrow is the time of technology, mainly of power sector, and if you learn things, the world will be yours. Thank you. Bye.
Thank you so much, sir, for your kind presence. Now, let's welcome Professor Somojit Bhomik, who is an IET YPS chairman of Kolkata Local Network, to say a few words about the webinar. Welcome, sir.
Thank you. Good evening, everyone, to the one and all present here. On behalf of the IET YPS section Kolkata local network, extended a warm welcome to the people in the gathering. Also, I extended my gratitude to our honorable speaker, Dr. Devashish Day, to take out time from his busy schedule to grace the today event. A special thank to Mr. Onkit Roy Ghatok and Mr. Nivan Chakraborty for providing support to make the webinar successful. I must thank the organizing team and volunteer for working hard for the last few days to make this webinar successful. And also thankful to Mr. Shankar Mukhopadhyay and also Mr. Susanto Ray to support this kind of webinar. And lastly, I am announced the small things. IIT Kolkata Local Network and YPS section of IIT Kolkata Local Network will organize a short-term course on future trend in AI in the months of November and December 2021. Basically, those students are third year and fourth year. Please, and also the faculty members, please join this course. The course is hours. Please join everyone. Thank you.
Thank you so much, sir, for the wonderful speech. Without wasting any more time, let's call upon Professor Oritra Ghosh, who is the Secretary of ITYPS Section, Kolkata Local Network, to talk about the webinar.
Hello, good afternoon, everyone, and good evening, actually.
Good evening.
I don't waste any more time, and I heard about Dr. Day's lecture before, and I think you will be gather some more knowledge about it. What IT does, IT actually the professional society, and you are the part of professional society, right? And actually we volunteer, we will shape the world, and try to be a member of professional society and try to shape the professional world very carefully. And moreover, the most important thing, try to volunteer in the program, try to participate in the program. I need and we need more and more participation from your end. Thank you very much. Thank you all.
Okay, there's an attendance link in the chat box. I request every participant to fill up the form. So now I would like to introduce our main speaker of the day, Dr. Devashish Day, who is the professor in computer science and engineering and director of School of Computational Science of Macau, West Bengal, India. And he received MTech from the University of Calcutta in 2002 and a PhD from Jadavpur University in 2005. He is a fellow IET member CSI. Welcome, sir.
Thank you, Ria. And thanks to all the participants for hearing me. And in the evening, good evening to everyone.
Good evening, sir.
Thank you, Shreya.
Hello, sir.
So can I share my slide? No?
Yes, sir. While sir shares the slide, I have an announcement for all the participants. Please note this very clearly. There will be 3 forms sent in the chat box during the webinar, 2 attendance forms and 1 feedback form. It is mandatory to fill up both the attendance forms to get the certificate. If one of the attendance forms aren't filled up, you will not get the certificate for the webinar. Thank you. So please continue.
So, and also mute everyone. Before start the lecture, mute everyone.
So is it visible now? Shreya?
Yes,
sir.
sir, it is
Yes,
visible.
sir.
Okay. Thank you for your for inviting me, and it's good to be work with IT, and it's wonderful to see almost 100 participants in this evening. And yes, I agree with Aritro and Shubhajit who have mentioned that IT is one of the leading professional society where people are working mostly in the field of electrical, and nowadays IET is for any engineering and technology branch can join. And I was also I can ask any question to the participants that what is the headquarters? Yeah, can you know what is the headquarters of IT? Anyone know?
UK.
Sir,
Yeah, is in London, right? It is in London, I think. So I was fortunate enough to visit that headquarters of IT, and I think 10, 12 years before. And it's a wonderful building, and wonderful people are there. And IT has publishes a lot of materials from IT journals are there. Also, you'll be happy to know that I am also working some of the areas of as editor in IT journals, IT quantum communication and communication engineering. So I was closely associated with IT for a long time, and thank you again. So today, without wasting my time, this time that I want to mention that today I'm going to discuss a very interesting topic. Already is mentioned by earlier speakers, especially the chairman Shankarnath Mukherjee sir has mentioned what is the implication of IET, means IoET, Internet of Energy Things, which is basically the extension of IoT, Internet of Things. So I have extra added this E, energy, E for energy. And this energy is actually a very important part of our life. You know that everyone know the price is increasing, right? Petrol price is almost century.
yes, sir.
So you understand the need of energy is energy, and energy management is very important. Energy generation of energy and also management of energy is very important. So Internet of Energy Things is today I will discuss how we'll manage the energy more efficiently in a smart fashion. As the other speaker mentioned that smart city, smart society, smart energy, smart metering system, right? Everything becomes smart. Because basically we are going towards industrial automation and more automation. Automation to more automation. And we are connecting everything in this world with the internet, right? Whatever may be the subject you are learning, whatever may be the appliances, consumer electronics are available, everything is connected. And everything is controlled by IoT. If you go to your market or go to Flipkart, Amazon, you will see that this IoT becomes not a buzzword, it is a bigger part and parcel of our life, right? If you want to purchase any camera, it is IoT enabled. If you want to purchase any laptop, you know, we have Wi-Fi and many other things there. We can connect it. Even our televisions are nowadays not normal TV. We call it smart TV, right? That means through, you know,
Yes, sir.
I have a Amazon TV, you know, Amazon smart card. I don't have any means normal TV connection. I see everything through my internet. Okay, I have a Wi-Fi in my house. Everything, all the channels, everything through internet only. So earlier, the concept was different. Now the concept is just pay per usage basis, right? So you can, you understand, we are all connected, and similarly, all our energy resources are also connected, right? Why we are talking about energy? There's two advantages. We have to make the system green. So I have intentionally kept this leaf, green leaves. This indicates that our intention is to make go green concept, right? So I am from this McCourt University. As you know that we have a center called Center of Mobile Cloud Computing. We call it CMCC, Center of Mobile Cloud Computing, where we perform this kind of measurement and analytics practically. And I'll show you some of the things what we have done. And this is the campus and this is our laboratory inside. So as I mentioned that in our Center of Mobile Cloud Computing, we measure everything in terms of mobility, right? If you see the vehicles, right? Cars are moving, your objects are moving, UAVs are moving, everything is moving, right? Even all the system is mobile. All this, not only your mobile phone, everything is mobile, right? You can take the television anywhere where the internet connection is there. You can get the internet connection, and through that we can see any channel, right? So mobility is part of our life, and edge-based mobility management is very important. So these are our areas. We are working on 5G and 6G network as well. Also, we are using this energy management. Especially, we are working on this renewable energy, blockchain-based IoT technologies. Also, see energy harvesting. Energy harvesting is another very important term, rather another very important technology. We must appreciate that based on the mobility, we can harvest the energy, right? This energy harvesting is not a new concept. You know that in the village areas, right? In the village cycles, bicycles, you have seen that paddling of bicycle generates energy, right? And through the mobility, we are creating the energy. So whatever I do research, I get that simple example of paddling the bicycle, and the mechanical energy is converted to electrical energy, and that is that is actually making the headlight on, right? Okay, so these are the very interesting areas. Energy harvesting is actually happening. So when you're talking about the cars are run by fossil fuels, right? Petrol, diesel, and other natural gases, right? You may know that statistics that energy is going down, especially in India. Coal energy and other energy resources are going down. So we have to think of the solar energies and other things. These are not alternative. These are all essential energy things are coming up. Even the cars with electrical cars, electrical buses. If you see the cities of Kolkata, Mumbai, and various parts of Bengaluru, Chennai, everywhere, the mobility-based energy harvesting as well as electrical vehicles are increasing, right? And that is a need of the hour, because petrol and diesel may go not 100, it can go for double century and triple century, like Virendra Sehwag, right? Okay, so it can play like Rohit Sharma or Virendra Sehwag. So you understand the energy is very, very important. So we need to go for green. Our aim is to reduce the energy, smart and safe. Our terminology, I want to mention that it should be smart and it should be safe. Smart means automatically connected, and safe means in the sense it should not harm. So we have to reduce the consumption of power. A few minutes before, Shankarnath Mukherjee sir has mentioned that when he was entering in his room, his ambience intelligence, we call it ambience intelligence, right? The sensors in his room is sensing that some person is within the room, and automatically his light, fan, AC will be on, right? So ambience intelligence is one of the very important computing, which is possible only through the smart sensors and smart IoT technologies, right? Through which we can make these lights on and off. And this is called sustainability. You know, the sustainable computing is the computing for the next generation. We have to make these energy resources at low cost and sustainable. That means low cost and affordable. If it is low cost, obviously it is affordable by everyone. So our main theme is green IoT, green and clean IoT. So we have to reduce the carbon footprint, and we have to take our world towards the future, right? Our footstep towards the future should be green. So in order to observe these parameters, what we want to say that we have to reduce the energy consumption, and greener IoT technologies should come up to build the next generation, right? So this is our target, that we have to develop the green energy system. That means energy system which consumes less power. So these are the agendas for today's topic. First is energy efficient architecture or algorithm. So whatever the algorithms we develop in terms of green IoT or Internet of Energy things, it should be energy efficient, and it should not consume much more power. So it's a job of the computer science people or these IoT people to develop the system in a software defined fashion. Everything is software. Nowadays, everything is software. Believe it or not, your smartwatch to your smart vehicles to your laptops to everything, your card, everything is software. And software engineering is one of the very powerful area who is working with these electrical engineers to work together to make the system, whole system energy efficient. That's the reason we can dream of smart city. Smart city is not dream. I think the first speaker has mentioned that smart city is not a dream nowadays. Smart city is a reality, right? So in order to develop the smart city, smart vehicles, we have to develop the green architecture. And everything is software based. Believe it or not, the companies like Mercedes-Benz. Mercedes, what kind of company it is? Shreya, can I ask Shreya or Shubhajit, anyone? What kind of company Mercedes-Benz is? Or Maruti, or?
It's a car company.
Car company. So what kind of engineers you expect? Generally, composition, say, if you consider 100%, then how much from mechanical, how much from electrical, how much from computer science? Can you just say?
Automobile engineer also required. Automobile engineer also required.
Automobile, I'm keeping in mechanical. Okay. So earlier it was around 80% from automobile, 80 to 90%. Only 10% is software engineer. Okay. And maybe 5 to 10% is electrical engineer. Do you know what is the present status? Any idea, anyone?
Not really, sir.
Just wild guess. Just wild guess. Okay. It's supposed to be more this automobile or mechanical engineer. But nowadays, believe it or not, these companies are coming up with 50% or more computer science people, means IT people. Those who are working software defined car, software defined network, SDN, we call it SDN, software defined network. And 20% to 25% is electrical engineer, right? The Elon Musk or some, they are coming up with India with various interesting car, right? And these cars will be all electrical car. Very interesting cars will be coming up maybe within 5 to 6 years. I was going through the news channel. So they are talking about this. See, that means automobile engineers from 80%, now it is reduced to 30 to 40%. Can you believe it? So it is more requirement of software engineers, more requirement of electrical engineers to develop this ecosystem of vehicles to work, right? So you understand that we need to develop energy efficient system. Second part is brownout. I'll discuss later on. Third is alternative energy resources. Fourth is energy harvesting. Fifth, green IoV, Internet of Vehicles, using Internet of Energy things. Last point I will try to mention about blockchain technology, which will make the energy resources secure and safe, right? Using IoT. So these are the agenda of today's talk. Now see, earlier we used to work in the cloud domain, right? For example, this meeting is happening in the Zoom platform, right? Zoom is nothing but a cloud platform, right?
Yes, sir.
So do you know the Zoom is basically US based company, one US company. Actually, we are storing all the data in their database, right? Whatever the meeting, I think you are also recording, or this recording is on. So, you know, whatever process is stored in the Zoom database, Zoom cloud server, I think you have to purchase this Zoom cloud service, and accordingly we are getting this this network is accessing, right? But when you are coming to this this energy, you know, this cloud consumes a lot of energy, but we have to make it green. We have to make the system IoT enabled. What is that? IoT enabled means IoT works in the ground level. In the ground level, that means my laptops can be connected to the sensors, my mobile phones, my cars. In a car, there are hundreds of sensors there in a car. Okay, even in your knitting machine or radio, you know, the taps, your mobile phones has thousands of sensors. So there's something is called edge cloud. Edge cloud is one of the very popular technology which is used for reducing the energy consumption, right? So we have to reduce the energy so that we can think of green network, right? So by this way, you can see the lower level, all the vehicles, all the objects, they are connected together through internet. What is actually IoT? If I ask you what is IoT, IoT is nothing but connecting all the objects, at the same time controlling the objects. Not only connecting, controlling also. IoT means connection and control. If it is only connection, then it's network only. So we can control using your mobile phone, we can control the sensor of your television, right? Using your mobile phone, I use my mobile phone to make my AC on, right? I make my mobile phone to make my TV on. So multifunctional mobile phones are available. Using this various kinds of Wi-Fi technology, we can connect your mobile phone in a multiple purpose. So it is all, these are all software defined design. And the cloud is called edge cloud, right? Edge cloud is very popular. And we have also written 2-3 books on edge computing. If you search on Google, you'll get it. Edge computing. And these edges are also intelligent edge. I think, you know, this is the age of AI, artificial intelligence. And AI is actually dominating the whole world. So edge has a lot of intelligence. At the same time, it is also reducing the power consumption. Okay. Because you want to send the data to the cloud and data will come back to the middle network called fog network. It will take a lot of energy. So we have to save the energy of the IoT resources. So by this process, connecting the objects using these edge devices or edge cloud, we can save the energy. So we can say our Internet of Energy things, or the things which is connected to the internet, we can reduce it. So it is a IoET is talking about how to manage the energy in a efficient fashion, right? Is it clear or not clear? Yeah, madam?
Sir, it is clear.
Yeah. So, you know, this, we do not have to go to the cloud. Now the question is, what is your age? So can you believe it? Your laptop, see, your laptop can act as an edge device. Your mobile phone, I think you have mobile phone, right? And your mobile phone is connected to the laptop. So any sensing, you say you are sensing a BP, blood pressure. I think I have also a smartwatch. My smartwatch is also connected to my mobile. And this mobile are also connected to the cloud. Means here, this laptop is acting as a cloud, mind it. This laptop is acting as a edge cloud. Edge cloud. I'm repeating, this laptop is acting as an edge cloud. Why it is going from this sensor to mobile to laptop? Because the laptop also has 16 GB RAM or 8 GB RAM. It is much more powerful than compared to your mobile phone, right? Agree? So we are going towards less powerful object to the more powerful object to perform certain job. We call it offloading, right? This process is transferring the job from one object to other object, one device to other device is called offloading. There are thousands of papers. Even we also published many papers in IEEE transaction. How to offload the energy means how to save the energy by offloading. Offloading is one of the very important factors. Offloading means you have to distribute the job. For example, I can see there are two the session chairs are there, right? They are controlling this full event where almost 112 participants are there, right? Now the question is, they are doing it on behalf of full system. Why? Because they're helping me to conduct this session powerfully. So my job of conducting this session is offloaded to Shreya, right? Shreya, is it clear?
Yes, sir. Yes, sir.
So you are doing this job on behalf of me. I can see a lot of people is admitting. I have to admit. I think you're also doing the same job parallelly, right?
So the people coordinating with us are allowing everyone into the meeting.
Exactly. So, in a college, there is a student level, there is a faculty level, there is a HOD level, there is a director level, also there is a vice chancellor level. So every time we offload our data. So any teachers, basically HOD offload the data to the faculty members. Offload means they distribute it. They distribute it and get the job done. So IoT is nothing but, IoET is nothing but distributing the job among the nearby devices and do the job in a very energy efficient fashion. Why? Because if you want to go to the cloud, there's a lot of communication cost is involved, right? A lot of energy will be wasted. Agree? Because this cloud is maybe at Mumbai, maybe in, if you think about this Zoom cloud, maybe in US or maybe in Mumbai or somewhere else, right? So it is consuming a lot of power. So we want to do all the jobs in the ground level and the edge level. So this is very important. And see, billions of edge device, but only thousands of cloud. So billion number is very high, right? So we can do this job very efficiently using this edge computing. So that is one of the very important part of this topic of edge computing. So if you see the research papers for last 2 years, edge computing is the most hit keyword means in the research level. If you go to the Google Scholar or anywhere, edge computing is most popular. It is similar synonym to IoT, right? It is synonym to Internet of Energy things, right? So when you are talking about energy efficiency of the system, we have to think about energy efficiency, resource allocation. We have to do the resource allocation in the cellular network in a energy efficient fashion. Now the question is why Shubhajit sir or your HOD has given the job to Shreya or other person, what is his name? Shreya?
So Riya is there with me.
Riya and Shreya. Why is Riya and Shreya? Because I think your HOD or your authority know that you can handle the job very efficiently. That's why the job is assigned to you. So similarly, we have to do the resource allocation. Resource means, see, you have conducted, the sessions, you have called the resource persons and you are conducting the sessions. So you have to allocate the resources, right? Similarly, if you can do this resource allocation in an energy efficient fashion, so your cellular network or mobile network become energy efficient. Okay. So you have to assign the job to the proper person and proper time. Then only you will get proper result. Yeah. So this is very important. Energy efficiency. So this is very important that we have to go for proper resource allocation. Right. So generally, the person who is expert in that domain, we assign the job to that one, right?
Yes, sir. Yes.
So, for example, in your say 10 friends, say 5 friends, you are going for puja pandal hopping, right? You ask the person who drive the car because he is expert in driving, right? So those will be sitting in the front seat, and they will be driving the pandal hopping, right? So who is the proper person. So your vice chancellor or your principal or your HOD knows who is the proper faculty, who is the proper student, those who can handle the job. So proper resource allocation is very important. Number one. Second thing I have already mentioned, energy harvesting. We have to harvest the energy. We have to generate the energy from any energy, mechanical energy to electrical energy. So machine to machine energy communication is very important, which is possible by energy harvesting. And we can transfer this energy through this internet from one place to other place, right? Another part is software defined machine to machine communications. Everything is software defined. Smart energy metering. Nowadays, the smart metering systems are coming up. So you will just get a SMS from your own meter. No people will come. Still, I can see CSC and other people, they're coming and checking the meter with the torchlight or something like that. So it is an old and primitive method. Those who are from electrical engineer, they know that smart metering is very popular and popularly used in various countries. Unfortunately, in India, not yet started, but we have to do it. If we want to make our city smart, we have to do it. Even you can measure every day how much energy you are consuming. I think that is possible through the metering system. Okay. Energy efficient task management by UAVs. Yes. Also various MIMO technologies are coming. So we have to think of the methodologies, right? We have to know what is our target. We have to have the green RFIDs and green wireless sensor network, green cloud computing, edge computing, green mobile to mobile network. So I am from computer science background. So we are using various technologies called PSO, particle swarm optimization, global optimization, GSO, energy harvesting, and green algorithm. And believe it or not, nowadays, many electrical engineers, I have seen in Calcutta University, Jitan Beda said, he is also working in this, I've seen they're working in this PSO. So it is a time of collaboration, right? Shubhaji said. So they are also working in this PSO domain to make the system energy efficient. Okay. So there is no boundary from electrical, computer science. Everyone is working in every domain, right? So that is the need of the hour. Everyone should work in a proper ecosystem so that we can generate the energy efficient systems, right? So I'm just skipping this. Okay, so we have to think about energy gateway when you're talking about controlling a whole system in IoT enabled system. You can see this is a energy gateways are there. There is a backend systems are there where you can see we are using energy efficient renewable energies, energy storage systems, energy charging system, vehicles. Vehicles are very popular. I started my discussion with fuel prices are going 100, double and triple century. Just wait few years, it will be double century and triple century. Okay. So we have to shift. This is the ultimate time. So we have to shift towards Internet of Vehicles domain. Okay, where most of the vehicles will be run by the software defined radios, we call SDR, or software defined network, SDN. Okay. So these are the scenario. Actually, we are moving towards green network. Okay. So what is green IoT? Internet of Energy or Internet of Energy Things is basically the implementation of IoT into distributed energy system to optimize the energy infrastructure and reduce the wastage. It's a very important definition. Just look at it. Internet of Energy and IoT, they're working together. Okay. And the system, ultimately we are developing a system, right? It can be a camera, it can be a refrigerator, it can be anything. It can be a washing machine also, right? We have to make a system which is energy efficient and connected through internet. So nowadays, see our microwave machine is also connected by IoT. I've seen many various advertisements on television. Have you seen noticed it that chimney, electric chimney is also IoT enabled, right? If you see Canon camera, that is IoT enabled. on the television, every time, every day we are looking at the advertisements. Why? We have to use the appliances, but in a energy efficient fashion. You know, there is a statistics that 50 to 60% energy is wasted because we do not switch off the light. So if you can make the ambient intelligence, that means what Shankar Nath sir has mentioned, that when he is entering to the light room, his light should be on and off, right? Automatically. And that is a good sign. Otherwise, you know, we have a very bad habit. We are going from one room to other room. My light fan is on and we are watching a 1 hour cricket match or 3 hours IPL match. Then returning back, still the light and fan is on. Okay.
Yes, sir.
Oh, this is the very, very important, very simple thing you have to understand. If you ask me what is the takeaway for today's talk, takeaway is we have to develop a model, means appliances. Your AC machine to washing machine to refrigerator to microwave machine, everything to energy efficient. And also reduce the wastage. This is very, very important. If you can reduce the wastage, we can 50% we can cut the electric bill. If your electric bill is 1,000 rupees, if you use this kind of IoT enabled system, I can tell you that your electricity bill will come 600 rupees instead of 1,000 rupees. Okay. And a lot of research already has been done. I think you are better expert. You know, you're all electrical engineering background mostly. So, you know, this is one of the big crime we do, right? We are talking about we should not waste our energy, right? Because you can afford money, but we should not waste our energy. That is a very important. Otherwise, it will have a huge impact to the power sector. So IoT and IoE, they're coming together. They're interoperability, right? So, you know, this IoT-based internet energy and internet-based IoT, they are all working hand to hand together. So power sector, they are working together. If you connect this IoT, then only we can make the system on and off, right? For example, when I go to college or my university, sometimes I think, oh, should I switch off my light? Sometimes it happens, yes or no? Sometimes you think, okay, maybe my fan is on. You want to check it. So how will check it? It is possible to check with your mobile phone app. You can check your house. You can make it switch on and off from your mobile phone itself. So these are the very simple energy consumption management using this IoT or IoT based energy systems, right? So see, I'm just not going to this. Everything is connected. Energy storage, renewables, everything is connected. Smart metering. So introduction of IoET, Internet of Energy things, we are actually reducing the power. Our aim is to reduce the power. See, there is a very interesting statistics. It's a little bit old statistics. China consumes this much amount of power, highest in the world, China. Third is US. Sorry, second is US. Third is in the IT sector. Can you believe it? IT sector is consuming the world. Third highest. And this is only, I'm talking about servers, cloud servers. If you combine all the electricity bills and everything, so it can be much more compared to maybe US, right? So you understand huge amount of, now you see India is here after the Russia, Japan, India, right? India is in, I think, 6th position in terms of power consumption. Why China is high? Because of industrial revolution. They have a lot of industry, US and after this. Now, you understand, we have to reduce this power in this energy. Question is how we'll do it. Every day our energy consumption is increasing, right? How we'll do it? Number of data centers is increasing. How we'll do it? Lots of cloud sectors are coming up, right? So believe it or not, nowadays, the recent statistics, nowadays many companies are using this unconventional, so-called unconventional energy, like solar energy, wind energy and biomass. And they are mostly running these servers using this solar. This yellow color indicates solar. This blue color indicates wind energy. So can you see this company like Google? Google is consuming huge amount, almost 90% Google data servers power is coming from where the wind energy. And wind energy is almost, wind is there. So there is a website called windy.com. You can install your server there. Agree? To generate the wind, nothing is required. You have to have the information where the wind is there. That's it. But if you see Amazon, almost 30% they are using the solar power and 70% is wind energy. So slowly, everyone is going towards various kinds of biomass or wind energy, these kind of things, right? So I think everyone has done your BTech, right? In your BTech level, you have studied a subject called data structure. Yes or no?
Yes, sir.
So in your data structure, you have heard about two types of complexity, right? Time complexity and space complexity, right?
Yes, sir.
So you have various sorting algorithms are there. So which is log n or kind of thing, right? N log n or kind of thing. Space complexity. But another dimension has been added. So this is it is a very new and open research area. It's called energy complexity. So your algorithm must not be power hungry. That means, that you have to reduce the power consumption. That means whatever the programs you're writing or what are the algorithms you're writing must consume less power. That is the concept. You know that Kumbhakarna, you heard about Kumbhakarna?
Yes, sir.
So Kumbhakarna algorithm is there, right? Kumbhakarna sleeps for a long time, right? He saves his energy. Why to waste his energy? But he's very powerful. He saves a lot of energy. So Kumbhakarna is one of the very interesting example of energy complexity. He can reduce his power consumption, but whenever is a need, Kumbhakarna, you have to wake up from his deep sleep and he can perform his job very efficiently. So we have to develop various algorithms in a very energy efficient fashion. So energy complexity is another very interesting area coming up. Okay. So I've given one of the example of migration of birds, right? Migration of birds is for load balancing. If I ask a question to you that why these birds migrate from one place to other place, can anyone say?
To adapt the environment, change in environment.
Yeah, adapt the environment and search of food, right? Food is another factor. The environment is one, food is another factor, food. So resource must be allocated to the accordingly. So it is a natural way. These birds move from one part to other part to get proper fresh water, fresh atmosphere, and the temperature, right? Similarly, inspired by this birds flocking or birds movement, if I say something that see, we have to develop certain model. We have to migrate the VM. VM means, anyone know what is VM? VM means virtual machine. Multi-cloud environment. There in a cloud environment, those who are from cloud computing domain, I want to mention that this cloud has lots of servers around the world. Cloud has lots of servers, thousands of servers, right? Say for example, Amazon, or your simple this Zoom platform. Zoom also has a lot of cloud platforms around the world, right? And they also migrate the job from one place to other place, like the birds. Where the server is free, our job is to allot that job. Means this Zoom platform or this cloud platform allot that job. For example, this meeting is on record, right? You're recording this meeting, right?
Yes, sir. Yes, sir. We're recording this meeting.
Where this VM will be stored, that depends. Job will be migrating from one place to other place. It can be stored in Singapore. It can be stored in Kolkata. It can be stored in Bangalore. It can be stored in US as well. Everything depends. What is the availability of the resource? Are you getting a point? For example, Kolkata server is not available. Maybe Mumbai server is available. So they will migrate the job from Kolkata server to the Mumbai server. Or if Kolkata, Mumbai, both the servers are busy, then the Zoom platform will migrate the job from Kolkata to maybe Singapore. So this is called VM migration. Clear? Is it clear?
Yes, sir.
Cloud is migrating the job. So this is the job kind of thing. If you can do it, it makes the system energy efficient. Why? Because there is a controller. It's called multi-cloud system. As we are working in the cloud domain, so I can tell you, cloud energy is very, very high. I have shown you in the slide, right? So we have to think, we have to develop the cloud system in an energy efficient fashion. So if you can migrate the job in proper location, we can save lot of energy. So Internet of Energy things, we call it IoE or Internet of Energy things, we can save lot of energy. Okay. So we have to search what is the nearest available location, right? And accordingly, we share or store the job. So this is called VM migration. Right? So this is the picture of Australia. Actually, I did my postdoc in Australia. So I did this one experiment. This is, anyone know Australia? This part is called Perth, right? Western Australia. This is Eastern Australia. This part, this is my university. My university is, I worked in Melbourne also sometimes. So this is my Melbourne University cloud. And this is my Perth University cloud. And there's some cloud broker is here. What is that? When the job is there, see, these servers are run by what? The solar powers, I told you, energy powers. So if there is a daytime, this side is east, this side is west. Agree? East to west.
Yes, yes. Yes, sir.
Fine. I was, I was fortunate enough to work 6 months in this Western Australia. Also 6 months in this place, Eastern Australia. Melbourne University, this is University of UWA, University of Western Australia. Okay. And rest this part is basically desert in Australia, right? So when the sunlight is coming, sunlight is coming from the east, right? Agree?
Yes, sir.
And when the sunlight is high in this eastern area, say sunlight first falls in Australia or Japan, then it comes to India, then it goes to UK, then it goes to other countries, Africa, US, and other places, right? So when the sunlight is very high in these places, then try to understand, using this IoT technology and using this, sensing this energy consumption, we can store our server data to the area where the sunlight is there. Agree? So for example, now in India it is evening, right? But if you see in Mumbai, 6 p.m. is still daylight, sunlight is there. So simply we can move this cloud recording to this Mumbai server. What is the advantage? Because Mumbai server is using the sunlight, right? Are you getting my point? Very important point.
I'm getting the point. Yes.
Because sunlight is available in that place, we can save the energy. Okay. So something is called broker, cloud broker. This broker will decide where is the resources, whether it's wind power or solar power kind of thing. Accordingly, the job will be allocated. According to the job will be allotted to those areas, right? Yeah. So there is a website called windy.com. Anyone has seen it? In the windy.com, it shows live. You want to see it? Windy.com. If you see the windy.com, it shows where is the energy. where the wind speed is very high, which area? Okay. You can see which area the wind speed is very high. And accordingly, we will place the server on those areas where the wind speed is very high. Yeah. If you want, I can show you the live demo to the windy. Those who have access of windy.com on your mobile phone, you can on it. You can make it on your mobile phone, please. Anyone has seen it? Windy.com. You can search it on your mobile phone, or also I'm also sharing it to you. Just give me a minute. Can you see this? The screen is visible, or this windy.com is visible in my?
Oh, sir, just the PPT is showing.
Okay, I'm just stopping the PPT. Stop sharing. Okay. Just give me a minute. Yeah. Is it visible now?
Yes, sir, visible.
Yes, sir.
So you can see from this website, this is windy.com. Anyone can see it. We can real-time monitor the speed of the wind. These are the speed of the wind. Can you see this? Speed of the wind. This lines are coming up. Can you see these lines?
Yes, sir.
Yes, sir.
Now, just imagine. There's a lot of water is there, right? But also there are a lot of countries there. Now, if you install your servers in those areas, what Google is doing, I just want to show you this because you can understand what I mean to discuss today. It's very important. Just look at it. My question is to say, Ria or anyone, that where you install this server? Where we will install this server? This company like Google or Amazon, where they will install the server? Which area?
The places where there is more wind.
Yes, 100%. Who said this?
Sir, I'm Shumok.
Yes, Shumok, you are 100% correct. You have to select those areas where the wind speed is high. Number one. Number two, see, these websites gives you the real-time idea of wind speed, right? So, if you know which area your server is, if you know which area is your server, what you can do, we can allot the job to those servers where the wind speed is high. Agree? This logic is okay?
Yes, sir.
Now, what is today's discussion? Today's topic is Internet of Energy Things, right? IoET. So if you connect all the servers to internet, all the energy resources areas to the internet, where the wind speed is very high, what is the advantage? If the wind speed is very high on those areas, the cost of the consumption is low. Cost is low. Ultimately, everything is economics, right? End of the day, everything is economics, cost. I'm talking about sustainable computing, right? Are you getting my point? This is very, very important just point I want to mention. Any question? So in those areas, wind speed is very high. You will install the servers there, and real time we can allot the job to those servers in those areas. Yeah, this is very important. And by this way, we can reduce the cost of the whole system. Yeah, we can reduce the cost. Is it clear?
Yes, sir.
Pramod, is it clear? No? So you understand how we are efficiently utilizing the resources, how we are efficiently reducing the cost. So our target is reducing the wastage and the cost. Cost is very important. Low cost is very important. Without low cost, a system will not sustainable, right? We cannot drive the car if the petrol price is 200 rupees, right? Who will pay for it? Okay, I'm stopping this. So is it visible now? Right.
Yes, so the PPT is visible.
Yeah. Okay. So there are various techniques are there called, we worked in this domain called GSO, low warm home optimization technique, to reduce this, this is a glowworm. In Bengali, we call it Jonaki Poka. See, there's a very interesting feature. They, they organize themselves in a very energy efficient fashion. And we are actually mimicking the sensor movement, energy movement of the whole system or the cloud movement. So we are actually following this pattern. So this is the all energy efficient system. We are reducing the power consumption. We are reducing the redundant movement. Redundant movement is not allowed. So I'm not going into details, but I just like to mention there are various bio-inspired techniques are there, algorithms are there, which is efficiently used to reduce the power consumption and increase the efficiency of the whole system. So I'm just skipping it. So this is the one of the very interesting example for PSO or the GSO to use for flying ad hoc network. FANET means for drones also. Drones movement should be energy efficient. Drone has a battery, right? Drone should not move in a arbitrary fashion. It should be moving in a very energy efficient fashion so that the drones can connect to each other. So these are all cluster of drones, clusters of drones, right? So drone movement is drone is very popular. One of the most popular technology for 2021 and coming years is drone technology. Everyone is using this drone technology, but one problem: drones are coming up with batteries, and battery power consumption is going down. Now, what is the solution? There are two solutions. Shomok, can you give me the solution? Any idea?
So can you just repeat the question?
Yeah, my question is, the drones are very popular. Agree? Drones are moving like this because the drones are also consuming a lot of power, and drones are having only battery based, right? Drones are battery based. Now, how we can make the drones energy efficient? A case study. I'm just giving a case study. My question is to you: how to make these drones flying for a unlimited amount of time without need of battery charging or this kind of thing? What
I
are the
don't know
probable
exactly.
solutions?
So we can use solar energy, sir.
Yes, number one, agree. Number two,
Wind.
Wind energy. You can yes. You can energy harvest. You can use the wind energy. You can harvest the energy, right? There are some already experiments are there. We can harvest the energy. See, drones are moving, right? Using this mobility, they can also generate the energy. Their movement energy or mechanical energy is converted to electrical energy. By this way, these drones are also generating the energy. And there are some autonomous drones without any proper charging, they can fly like this. These techniques are coming up. These technologies are coming up, right? And also the movement of the cluster, like a birds, right? 4 birds are moving like a flock of birds. They're all inspired by the inspired technologies. So these are the 4 steps, the 4 methods. By this way, we can reduce the energy conversion. Clear? So I'm just keeping this. So we have shown you already that this a lot of energy consumption we have reduced. This is one of our research paper in ad hoc network where we have worked in this reverse GSO mode. where we have used this wireless sensor network movement in a very energy efficient fashion. See, the grid mobility in an energy efficient fashion. Energy efficiency is one of the very important. So I'm skipping this. Also, we have used fuzzy logic. Fuzzy logic is one of the soft computing technique. Fuzzy logic with GSO is another very interesting area. Our energy and coverage. Ultimately, see, energy, we are doing green network, green mobile sensor network. So this is our target, and we are working on this area for a long time. Another technique is called brownout. What is brownout? Anyone know? In COVID time, we have brownout. Brownout means we cannot go outside home frequently, right? We are giving lecture. Generally, we used to give the lecture in front of you. Now see, we are on the Zoom platform. We are giving lecture like this, right? So our movement is restricted. Our power consumption is restricted. So in a restricted zone, this is known as brownout condition. One of our research scholars did PhD in this topic, brownout. Anyone is interested, I can share you. Send me a WhatsApp message, I'll share you whole thing. So it will take maybe another 2 hours to discuss brownout. Okay. So if there is any energy constrained area, like during the lockdown, we cannot go to the restaurant, right? We cannot go for lavishly eating food here and there, right? We cannot go outside. So sometimes in area where the energy consumption is restricted, there is some policy. It's called brownout policy, where using these machine learning techniques, we can use this our resources, and it's called SLA, called service level agreements are there. We can manage the power consumption, and we have observed that in the smart city domain, we did this experiment in Denver. Denver is one of the very popular city in Europe, and even in the renewable energies are very much used. When normal power consumption is less, renewable energies are mostly used. I can give you one example. In US, almost everyone makes the water pump on in the night. Why, anyone can say?
So, because at night the power consumption across the households are less once people go off to sleep, so the pressure on the source to which the energy is coming will be less, because usually pumps consume a lot of power.
That is a different angle. I'm talking about a different angle. I'm talking about, that something is called busy hour. Busy hour, nowadays, I use Vodafone. My Vodafone night to morning from 12 to 6, it is free. Any amount of internet I can use. Why, because traffic is less. Similarly, in the power sector, unfortunately, this kind of concept is not in India, but surely it will come. If you consume the same unit, say if you are consuming 10 units of power, in the day, it will be costing you 20 rupees or $20, right? If you do the same thing in the night, you know what is the power cost? $5 only. Are you getting my point?
Yes, sir.
Yes, sir.
See, I am talking about two important things. Economics. See, from the beginning, I am talking about reducing the wastage, and I'm talking about the cost. Cost is one of the very important factors. Why in the night, in US or many other smart cities, basically, everyone go to sleep, and less power consumption is happening. The industries are generally down, means not working, everyone. So in the night, the powers are not much required. That time, they are giving much for 50% discount or maybe 60% discount in the power consumption. So that is the reason they are actually encouraging the people to use this pump at the night. And this is not a story. This is actually happening in various countries in Europe and other countries. Unfortunately, I don't know why India, we are not using it. Maybe for the noise. We have a lot of noise in our pump. That will hamper your sleep. Otherwise, similarly, in the power consumption mode, see in the brownout consumption means when the coal energy is reduced, the renewable energy is playing a major role. So it is a combination of coal energy and renewable energy. Coal means fossil fuels and renewable energy. It's a combination. So nowadays, power management, especially Internet of Things or Internet of Energy things, it is a combination of fossil fuel power and solar energy power or the wind power. Yeah. So by this way, by this combination, actually we are actually getting out of the problem called brownout condition. Brownout. Listen, those are from electrical engineer. These are a very, very important term, brownout. That means resource constraint area. Resource constraint, right? So I'm not skipping this. So mobile edge computing. Recently, I have published one book on mobile edge computing. It is in Springer. Those who are interested, they can see it. Using this mobile edge computing, we have shown that reduces the power drastically. For the shortage of time, I'm not discussing everything, but those who are interested, I can share you the PDF. You can see we have full book of 700 pages. 606 pages. Full book we have written, and we have edited this book, and very interesting chapters are there. How to reduce the power in the energy mode, energy efficient mode, right? So skipping this. Yes, there are photovoltaics. Those are coming up with this kind of This is a very interesting drone design, right? With this photovoltaic. I think Shomok has mentioned, right? Shomok, can you say this?
Yes, sir.
So this is the very interesting design, isn't it? For the drones, these are very interesting photovoltaic designs. See, some more designs are here. And these drones can connect to each other also. One drone can connect to other drones using these IoT protocols. I think I can see Amorto Mukherjee is also there. He is also from faculty member of IEM. He has written many papers on this domain. Amorto, you can contact Amorto also. See, this Amorto is here, isn't? No. So see, these are all the very interesting drones are available here. That they are connecting to each other using this photovoltaic power. So I'm just keeping it. Yeah, this is Amorto, where you can see edge drone. We have developed edge drone. We have published this year, last year, 2020. Edge-based drone for reducing these power consumption models. We developed this drone in an energy efficient fashion. So these are the various modules. I'm not going in details. How these drones can talk to each other. They can communicate to each other in a very interesting and energy efficient fashion. Drones can talk to each other using this energy consumption. Power grid. See, those who are from electrical engineers are very interested in power grid. These drones are also playing a very important role for load forecasting in the power grids. This thing we have published in last year, August, almost 1 year before. Amorto and Pratiti, both of them are part of IEM computer science department. And see, we have done very small simulation models through which we are giving this power to the smart grids in the whole system. Okay. This is self-explanatory. Basically, drones are actually helping to the smart grids to load balance in the whole system. So these are some of the snapshots of our experiment. So this is one of the very interesting drones, which is underwater drone. We also have worked on IoET, Internet of Underwater Things. So these drones are playing a major role. So I've already mentioned some of the energy harvesting system. Energy harvesting is one of the most popular area of green IoT. In energy harvesting for renewable energy,
এখানটায় দেখো এই লাইটটা খালি ব্লিঙ্ক করছে, বলবে এটা নাহলে আমার জন্য ওয়েট করতে হবে না। যদি বলে না ফার্স্টে বলবে ওই ওয়ারেন্টি কাগজটা দিন। অরিত্র প্লিজ মিউট ইয়োরসেলফ, অরিত্র প্লিজ মিউট ইয়োরসেলফ।
I'll just take 2-3 minutes more. I'll stop it. I know that I've taken a lot of time. So see, these are the some companies that develop some semiconductor companies. Cypress Semiconductor. They have made a chip. When the drones are flying, the microcontroller can generate the electricity. So it is one of the very popular energy harvesting technology. Technology is empowered by PwC, and the company is Cypress. Okay. And blockchain is another very interesting area to make the system secure enough. Blockchain-based energy is very popular. We are also working extensively in this domain. Why blockchain can make the system secure? Because some of the cyber attacks are very common. If the cyber attack comes, I think those who are working in this power system, they know that this attack can halt a system or the country, full blackout of a country or a certain area. So in order to mitigate it, blockchain is coming up in a big way, and all the systems, all the power consumption can be monitored and managed in an efficient fashion. So these are the power credit bank, this is the aggregator through which we are distributing the powers using the blockchain technology. See, this is the blockchain is very popular, very, very popular. But this is another vast topic. You'll be happy to know that we have published one book called Blockchain-based IoT, Internet of Things, where we have combined this all energy blocks together and did this energy harvesting operations to make the system in a very efficient fashion. And so these are the very interesting areas called microgrids, energy harvesting, vehicle to vehicle connection, vehicle to grid connections. You know, electrical vehicles are coming up. Elon Musk is investing into India for his electrical vehicles. So these are the another some interesting some areas those who are people are working. And 7 possible cases: microgrid, peer-to-peer energy trading, you know, electrical cars, reducing the carbon footprint, clean energy, green energy. So these are the buzzwords are coming up. So when you're talking about Internet of Energy things, without blockchain, nowadays it is incomplete. But these are the vast areas, very vast area. I cannot go to all these things. But what I mean to say that when you want to develop the system must be cost effective. So this is the goal of sustainability goals by UNESCO, right? They have given, they have given this 17 goals. Everyone should know. This is my last slide actually. No poverty, zero hunger, see, well-being, quality of food, clean and water. See, this is very important. 7th one, affordable and clean energy. Today's topic is based on this 7th point, affordable and clean energy. Not only green, it is clean also, affordable. See this term, affordable, very important term, right? I hope that what are some of the ideas I have given within a very short span of time. I hope these ideas will help us to work together in a collaborative fashion. I have already shared my email ID and mobile number. It is available with Shubhajit. So those who are interested, they can also work in this domain, affordable and green energy, so that we can develop a sustainable world. And these are some of the books I've mentioned as mobile edge computing, which is very popular. And I've discussed also some of the green mobile cloud computing, also nature inspired computing or hybrid intelligence, which is helping to develop this Internet of Energy things in a very popular fashion. With this, I stop here. Thank you. Thank you. Thank you, Raman.
Sir, thank you, sir.
Thank you so much, sir, for taking out time from your busy schedule and being present with us today. Thank you so much. Okay, so if any participants have any questions, you can write it down in the chat box and I will read them out to sir. Please feel free to ask questions. Okay, sir, Shomak Kumar asks how to convert cloud energy into edge level energy to optimize energy consumption.
Yeah, actually, we should not go to the cloud. All the times, you should not ask principal to solve the problem, right? We can ask our HOD or we can ask faculty level, any problem, any student, right? So we can solve it by ground level. We should not go to the cloud. We can store, we can resolve the problem in the energy, means in the lower level, means in the edge level, which is in the IoT level, which is the ground level, right? By this process, we can still save the energy.
The second question is, can solar panel or solar cells be used in auto intensity control street lines, street lights?
Yes, it is already used, frequently used nowadays. Yeah.
Okay, so any more questions? Please feel free to ask questions. I'm again repeating this. All the participants, please note there will be 3 forms sent in the chat box during the whole webinar, 2 attendance forms and 1 feedback form. It is mandatory to fill up both the attendance forms to get the certificate. So I'm guessing there are no more questions.
A lot of questions I can see in the chat box. Lot of questions.
1 minute. Yes, the link will be sent.
Yeah.
So these aren't questions. These are about the attendance link.
Okay.
Just one quick question, sir. Like, I'd like to ask. Since you have a great background in research and you're publishing papers and stuff, and these are books, so can you tell how we as engineers, we as basic bachelor's degree holders, how we can get into research and how we can get into paper publishing and even like book writing processes? Can you like share your own story, how you got so far and so ahead, and how we can like join you in the quest?
See, I can tell you, if you are interested, see, it is all about your interest, right? I also, that I worked for software engineers. I was in Cognitive Technology Solutions. I worked for various other companies as well, even for government of India also. So if you have interest, no one can stop you. First, you have to have the interest on the subject. Then I have shared my email ID and mobile number and WhatsApp. So those who are interested, they can, they can contact me. I think I've written around 15, 16 books. So I can share you the books and all the materials. So it is a, yes, I'm from basically a computer science background and all those areas. So yes, we can collaborate and we can work together in this domain of electrical engineering and also especially for IoT and to make the system energy efficient fashion. Yes, we can work together, no problem. We work, that if you ask me that if we work day and night, it is your passion. It's all your passion. And believe it or not, best students are from BTech level. That is my observation. So we got best students and best output from BTech level. So they are the best. Everyone is good, but they are the best. So if you have any, I have no barrier. I'm always free. You can talk to me anytime. I'll respond.
Also, someone has asked for the PPT in the chat box. This whole webinar will be available on the IET YouTube channel. So you can check it out over there.
Yeah, IEM is very efficiently handling this resources. I know that all the lectures are there. So I think they're freely available, right? Freely they can see that. Yeah, madam.
Yes.
Yeah.
Everything's available.
So Harikhan, you are, Farhan Harikhan, you are.
Yeah, Farhan. Yeah.
Farhan, you can freely, if you are interested, you can work, no problem. Any small domain we can work.
Yeah, sure, sir. It would be an honor.
Every big things comes with small only.
Right, sir.
So it is all about your experience and all these things, how you want to work. So yesterday, some of the newspaper people they're asking me that how you got to the 2% scientists in the world. So I said that this is not my contribution. This is total contribution by my students only, because they have contributed. That's why I have around 700 publications. That's why my name is in that top 2%. So it is only you only, right?
Right, sir. Right.
It is a combined collaborative effort.
Yes, we're sending the second link. Just give us 2 minutes.
And you're a student or?
Yeah, sir. I'm the vice president of IET, and I am interested into research. So that particular question was research oriented. Yeah.
From which college? IM.
Yeah. I'm from IM.
IM electrical department.
Yes, sir.
And especially, the interdisciplinary research is very important. And that.
Right, sir. Right.
I have less idea about electrical engineering, but I have some idea about computer science, electronics, and all these things. So if everyone works in this domain, then the system becomes much more robust and powerful.
Right, sir. Right.
That's why collaboration is very important. Proper collaboration is very important.
Yeah.
So everyone should feel free to ask and feel free to discuss.
Participants, you can find the feedback
The
link in the
second
chat
link has been
box.
given in the chat box.
So Shreya, is there any no more
I don't think
questions?
so there are any more questions. So you people, the participants, you people can fill up the forms.
Yeah, and the feedback form is meant for you guys, because like we will be expecting to have great sessions like this with sir, and so we need feedback from you guys that like where can we improve and stuff. So do fill that out.
Okay. Now I would like to call upon
Yeah, 1 minute. Sir, you can stop your screen sharing. Sir. Yes, share now.
Now I would like to call upon Nirvan Chakraborty sir, member of IET YPS section of Kolkata local network, to give the vote of thanks.
Thank you very much, sir, for this session with us. We were very much happy and privileged that you were agree with this kind of things. And as we know that energy sector is going on in a very vast change, so the things like small thing like IoT, machine learning, those kind of things are very much now meaningful in this kind of trends, because as sir has also mentioned that then US and UK, all the others country are using the power management scheme, but for the very funny reasons India are not so much there. But we hope that in future it will be there, and we can see the lots of applications of IoT, that like the smart devices that as the sir mentioned, like smart grid, smart cities, all those kinds of things, so that our daily life can be very great. So thank you again, sir. We on the behalf of the IET YPS section would like to present this small plaque to you for this wonderful session. And we hope that in future we will have many more this kind of session with us in offline mode, not in like this online mode, in offline mode. Thank you again, sir.
Thank you. Thank you very much.
Please make sure you fill up the feedback form too. We would really like to know your feedback on this webinar so that we can make any changes or improvement by seeing your suggestions. Ria, you can conclude the session.
Yes. So thank you again, Devashish sir, for answering those questions and for the great presentation. It was pleasure to have you with us. Hope you all enjoyed this amazing presentation. So this concludes the webinar. Thank you all for attending. We hope you have learned and enjoyed the session. Thank you, everyone.
Thank you.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir. Thank you, sir.
Bye, everyone.
Thank you, sir.
Thank you.